Hello and welcome to this tutorial. In this video, we'll explore a method for creating Lego-like bricks using a procedural shader. We will first convert our geometry to a blocky look by copying some cubes to it, and then we'll set up the shader to create the studs on top at render time. Hopefully, this tutorial will challenge your perspective on shader setups, and you'll find some valuable information that you can apply to solve a wide range of other problems. So for this tutorial, I'll be using Houdini and Material X, but the information in this video can really be applied to any application that gives you access to the similar nodes that we'll be using here. So let's dive in. I'll first create some geometry here. I'll use the SOP create node for that. Let's put that down and dive in. And I'll use the USD import node to bring in my geometry. And let me just quickly get a path to that. The model I'm using here was downloaded from Polyhaven, and I'll put a link to that in the description. All right, I'll use a transform node to position this correctly. So let me rotate this and scale this up. And let's copy some cubes to it to give it that sort of a blocky look, like it was made with those Lego bricks. So for that, I'll need some points, and I'm going to use the points from volume node. Points from volume. And nothing shows up. That's because our USD has not been unpacked. And I'll also convert it to polygons. Right, let's create our cube. And let's do a copy to points. And I think I need to scale this down to, let's say, 0.1. And actually, I'll leave it to 0.105 just to give them a little bit of an overlap to make sure there's no gaps between them. Okay. Next, let's bring our texture map that we got with this model and apply that to this blocky version of the model. So for that, I'm going to use the attribute VOP node, connect the transform to the attribute VOP, and I'll just go to the transform node and click on the node info to make note of the UV attribute. So in this case, it's called UV map. We need to make sure that we can spell this correctly, otherwise this won't work. We'll go back to the attribute VOP, put the display flag, and dive in. Right, let me make some space. And here I can use the color map node to read in the texture. Color map. Let me get the path to the texture. And I'll connect the output of the color map to the CD for our geometry output. Well, we see something, but the map isn't applied correctly because we haven't given it any of the UV coordinates. And to do that, I need to bring in our vertex attribute. So import vertex attribute node. Import vertex attribute. And let's put this to vector 2 since it's a UV attribute. First input, and the name of the attribute was UV map. I'm going to take the vector 2 and split it into its float components. And now I can plug this into the U and V input of the color map, and that's going to help us get the map applied correctly. All right, let's go back out. I'm going to transfer this CD attribute to the points. And after the copy to points, I'm going to promote this to primitives. Oops, let's the other way around. Right. Now, we have a lot of these blocks copied on the inside of this geometry, which we don't want. We just want the outside layer. So just to show you what I mean, I'm going to use the clip node. Let's do it the other direction. And you can see that the inside volume of this entire mesh is filled with these cubes. Well, that's because we use the points from volume node that actually also puts in points on the inside of the volume, not on just the outside surface, hence the name points from volume. So to fix that, I can use a Boolean union node, connect it after the attribute promote. This might take a few seconds to calculate, but this would actually fuse all of these boxes together and will give us a hollow cavity on the inside and just the outside skin. And that's what we're interested in. So if I now connect this to the clip node, let me make a duplicate of this. You'll see that the inside, we've gotten rid of all of the cubes that we had, and we only have this outside skin left. Well, That's why we scaled this box up to a value of 1.05. We needed that little bit extra for an overlap to make sure that this Boolean node can calculate correctly. If the overlap is not enough, it might miss some boxes and we still have some mesh on the inside of our model here, which is what we don't need. So I'm going to get rid of these clip nodes since we don't need them. And now I'm going to put down the output node. And I guess between the Boolean and output, I don't want this Boolean to calculate every time. So I'm just going to use the stash node to stash the results of this Boolean. So hit stash input, and that's it. So let's go back out and let's start working on our material setup. So we would need a material library for that. Connect it together. I'm going to turn on assigned geometry, and I'm also going to drag my geometry over to this geometry path field. That way, any material we create inside the material library will actually get assigned to this geometry. Let's dive inside, and I'm going to create a material X builder node. I'm going to call this the Lego material. And let's start by creating the setup for our studs. Now, we don't have any UVs. We never calculated any UVs for this. So we're going to just use the position of the object to calculate some UVs and go from there. So I'm going to get the position node, and I'm going to separate out the components. For this one, we would only need the X and Z components, so I can combine those back into a vector 2. And now this essentially becomes our UVs. Let me just visualize this by plugging this into base color. I'll also expand this group. Come on, right, there you go. So that's what the UVs look like. Now I need to tile these UVs. So I'm going to use a multiply node and a modulo node, so we can see what it looks like. Connect all of this together. And let's multiply this with a value of 10 by 10. Well, this has now created our UV tiles. And I know it's a little hard to see, and that's because our blocks and our UV tiles are not completely lined up. So the corner of the UV tile is actually in the middle of our block. So let's create a little bit of an offset here. So after the multiply, I'll do an add node and add a value of 0.5 and 0.5. Now the UVs sit squarely on top of our blocks. All right, that's great. Next, I need to create the stud shape itself. So a little circle. I want to make a little circle right here in the middle of all these tiles. And for that, I can use the distance node. Now the distance node will calculate the distance of between two vectors. So it's going to take the first vector, which we have all of our UV tiles, and the second vector is going to be right here. Now the UV tiles, if I just go back to those, they are calculated in a 0 to 1 space. So the one corner, I believe this corner might be 0, and then this is 1 in the x-axis, this is 1 in the y-axis, and this top corner is 1 in x and y. So it's comparing the distance of this vector 0, 0, which would be at the corner of the tile, and hence we see this corner is getting darker. Well, we need the distance to be calculated from the middle of the tile, and the middle value is going to be 0.5 in x and 0.5 in y. So let's put that here, 0.5 in x and 0.5 in y, and we can see that we have actually created a circle right in the middle of this tile. I'm going to use a range node to control the gradient and the size of this. Let's give it a value of, well, let's see, 0.3 and 0.35. And I need it to be inverted. I need the stud itself to be white and the rest of the block to be black. So I can just use an invert node. And that's the stud shape created. But we have a problem. We also have these studs created at the bottom of every tile, and we need to somehow create a mask so we can only have these studs on any of the faces facing up in positive y. Well, we can use the normals for that. So I'm going to read in the normals of the object by using the normal node. I can separate the vector since I need access to only the component facing in the up direction, which is going to be the y-axis. And let's visualize this. So that's my component. It looks a little messy right now because I don't have my render turned on. Let's turn on the renderer, and you'll see that we have all of the faces that are facing up in positive y are actually colored white here, and everything else is black. Well, there could be some values leaking here and there. Some faces could have a value of more than 0 for its y component. So I want to make sure that we can filter those out. And I'm going to do that by creating a greater node. I think it's called the if greater node. And I'm going to compare if the y component is greater than 0.9, which means if it's between 0.9 and 1, essentially, then I want it to output a value of 1. Otherwise, it can output a value of 0. Let's connect this together. You might not see any change. Let's multiply this with our invert node and wait for it to calculate. And here we have all of our studs displayed correctly on the faces that are facing up in the positive y-axis, and nothing on the faces that are facing down in the y-axis. Okay, that looks good. Next, let's bring our color map, the color information we put on this object. Let's read that in. So I'm going to use the geometry property value node, set the signature to color. The geometry property, although we did use the CD attribute when we were in the geometry context, once we come to Solaris, it gets converted to a property called display color. So let's put that here, display color. And let's connect this to the base color of the standard surface. And now we have access to our color attribute. And these studs, I can plug them into the displacement. Well, displacement is quite crazy right now. So I'm going to set this to a value of, let's say, 0.1 or 0.01. And that seems to be the correct value. But we have these studs more looking like little cones than the Lego-like studs that we want. So I'm going to go back to the range node and turn on clamp. And that should fix that. Maybe we can scale this up a little bit to 0.2. And that's it. That's our setup for creating a Lego material that creates these studs at render time. Thanks for watching.